On today's episode, to get robots in every home, it's about actuators, not AI. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Now, we've all seen the remarkable videos of humanoid robots from companies like Boston Dynamics and more recently Tesla, and they move with remarkable agility. Bipedal motion has never been easy to master. Ask a toddler, and keeping a relatively heavy machine with a high center of mass operating on 2 feet is a heck of an achievement. Now, where robotics really matter in industry, SCARA robots are now available to do everything from subminiature printed circuit boards to welding of structural steel. So why is it taking so long to get household consumer robotics in our homes? Now, it's widely assumed that the rate-limiting step in the general application of robotics is code and processor power. Well, it isn't. The problem that needs to be solved is cost and good old-fashioned mechanical engineering. And I think a realistic understanding of what the end user, consumers, want from the technology. The high-volume market, however, will be household robotics, and for that application, the machine has to be a personal assistant, a combination of maid, valet, and possibly chauffeur. Now, self-driving cars can already handle much of the driving duties, and there are simple machines to vacuum your floors or mow your lawn. But homes are designed for people, and this new generation of bipedal humanoid robots can interface perfectly into that environment. The machine we all need and want will clean bathrooms and kitchens, do the laundry, make a simple meal. Now, the code and processor power necessary to handle those basic object recognition and manipulation tasks already exists, and it doesn't require artificial intelligence. Building that capability into an affordable machine, however, is the challenge. A step forward is the migration away from hydraulics and toward electric actuators. Servo and stepper motors, ball screw linears, and other electromechanical devices are replacing pumps and cylinders. This reduces cost and energy demands and should make the units lighter. Now, Boston Dynamics has already gone in this direction with their replacement for the highly capable Atlas robot. But cost scales exponentially with precision and accuracy in pick-and-place tasks. For a machine that washes pots and pans, exactly what level of accuracy and repeatability is necessary in the end effector? It isn't 1/10 of a millimeter, and it might be as loose as plus or minus a centimeter. Could you loosen tolerances to as much as 1 inch for grasping an object and putting it on a shelf? Well, yes, if the machine vision systems can recognize the context of the task. Inserting an extension cord into an outlet will require both accuracy and repeatability. Folding a towel, less so. Now, as usual, everything will hinge on cost. For widespread adoption, these things are probably going to have a price point that allows monthly financing or lease payments that are roughly similar to a car, suggesting that manufacturers will need to turn these things out at something in the neighborhood of $40,000 to get widescale uptake. Now, if designed properly, the machines could be durable enough to carry a residual value, creating a secondary market for used equipment to allow monthly payments that could be affordable for the majority of households. To achieve this, the robot makers are going to have to stop thinking like NASA and rethink things like titanium and carbon fiber, commodity plastic resins, utility-grade aluminum alloys, and critically, affordable batteries will be the way forward. Like electric cars, batteries may be the limiting step. But a robot that needs 15 minutes of self-charging for every 45 minutes of work would still be a useful tool. Now, it's been predicted since the Jetsons. So when can I place my order? Well, that's it for today's episode of End of the Line, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.